Liftoff, Falcon 9.
Good morning. It's Wednesday, June 12th, and we're here at SpaceX headquarters in Hawthorne, California. You're looking at a live view of the white velvet fog that surrounds Falcon 9 as it awaits its 7:17 a.m. Pacific time launch from the Vandenberg Air Force Base launch site in California. My name is Kate Tice, and I'm an engineer in the Build and Flight Reliability Department here at SpaceX. Welcome to the webcast for the Radarsat Constellation mission. For today's launch, we will be flying 3 satellites for our customer, MDA. All 3 of these satellites are for the Canadian Space Agency to help enhance maritime surveillance, disaster management, and environmental monitoring. This morning, we have a 13-minute launch window that closes at 7:30 a.m. Pacific. We're currently at T-minus 11 minutes and 19 seconds and counting. All systems are currently go. So as you can see on your screen there, it's very foggy at Vandenberg today. Our view is completely obstructed, and that's pretty common for Vandenberg. But as you can see above the clouds, it is a clear day. Now, if we were able to see the launch pad itself, you would see something that looks more like the model that I have here next to me. Falcon 9 is our 70-meter, 2-stage liquid-fueled launch vehicle. The bottom 2/3 of the vehicle is the first stage, and that accelerates the vehicle through the Earth's atmosphere to the edge of space with the help of 9 Merlin engines located here at the bottom. Today, we will be attempting to recover this first stage for the second time at our landing zone Slick 4 East. This booster flew for the first time earlier this year on our Demo 1 mission for NASA. On top of the first stage is the inner stage, which is black, as you would be able to see if we could peer through the fog there. And then on top of the inner stage is the second stage. And the 2 stages separate about 2.5 minutes into flight. And the first stage is the portion of the rocket that we are attempting to recover today. The second stage has a single Merlin vacuum engine, or MVAC, which ignites after the first stage separates. The second stage is what will carry the 3 Radarsat satellites to sun-synchronous low Earth orbit at an altitude of 600 kilometers above the Earth's surface. That's roughly the distance from Los Angeles to San Francisco. Sun-synchronous orbit basically means that the satellite will pass over the same section of Earth at the same time each day. Now, those satellites are safely enclosed inside of the 17-foot diameter payload fairing, which is the pointed cone at the very top of the rocket. This portion of the rocket helps protect the payload from aerothermal loads, heating, and contamination during ascent. Once we reach the vacuum of space, we will jettison the fairing as the second stage continues on its journey to orbit. Because our recovery vessels are currently at the Cape, we will not be attempting to recover the fairing halves today, but it is something that we will continue to pursue on future missions. Lastly, the large truss structure that you would normally see out at the pad is the Transporter Erector, or TE. We use that to roll the rocket out to the pad and raise it to its vertical launch position. The TE also routes the vehicle's fluids, power, and telemetry umbilicals from the ground systems to the rocket and satellites until F9 goes on internal power and clears the pad. At liftoff, it'll retract in order to clear the way for F9's ascent. Falcon 9 rolled out onto the pad with the payload on June 11th. The chief engineer held a technical poll at T-minus 1 hour, and the launch director held a propellant load and launch readiness poll at T-minus 38 minutes. Falcon 9 has been loading propellant since T-minus 35 minutes. F9 uses rocket-grade kerosene, or you hear us call that RP1, for its fuel and liquid oxygen, or LOX, as the oxidizer. With fuel and oxidizer on hand, we need an ignition source to complete the fire triangle. For this, Falcon 9 uses TTEB, which will be seen at T-minus 0 with a bright green flash down here near the engine section. At this point, we are proceeding through prop loading nominally. It looks like we are nearly complete for LOX and fuel on first stage, complete on fuel for second stage, and about halfway through LOX load on second stage. So there are a couple of important activities coming up in the next couple of minutes. At T-7, we will begin engine chill. This is where we allow a small amount of the super chilled LOX to flow into the engine's turbo pumps prior to the full flow of LOX through the Merlin engines. We do this to avoid any thermal shocks to the hardware. Normally, you might at this point see large plumes of white gas coming from out around the rocket. Of course, we have fog acting as that white plume of gas, but that normally would just be the liquid oxygen vaporizing as it makes contact with the air around the rocket. Also, around T-4.5 minutes, the transporter erector will retract from the rocket slightly to give Falcon 9 clearance for liftoff. At this point, we have also begun helium loading. The vehicle uses helium gas as a pressurant to push the RP-1 and LOX through the Merlin engines. If you think about drinking from a soft plastic water bottle, you let air back into the bottle when you're done sipping, which prevents the bottle from crinkling up. Helium is what keeps the rocket from crinkling as we use up the RP-1 and LOX within the stage. Now, as far as the spacecraft at the top of the rocket, the 3 Radarsat satellites will remain off until after separation from the launch vehicle. Right now, the vehicle is healthy and we are currently tracking no issues. Aside from the fog, which doesn't impose any violation of our launch weather conditions, we are green. The range is also green and prepared to support today's mission. We continue to count down to liftoff in just about 6 minutes. If for some reason we do have a call in, if for some reason we have to call a hold on today's launch, we do have a backup opportunity tomorrow at the same time. Today's mission is for our customer MDA on behalf of the Canadian Government Space Agency. The 3 Radarsat satellites will help the Canadian government monitor key areas including maritime, disaster, and environmental surveillance. As mentioned, today's payloads will be delivered to sun-synchronous orbit. Sun-synchronous orbits travel over the Earth's poles as the planet rotates underneath, with the satellites passing over a particular section of the Earth at the same time each day. Let's get some additional details on how these satellites will serve the Canadian government.
Our country is vast, with very different challenges, from coast to coast to coast. With the help of satellite technology, the Canadian Space Agency provides solutions to some of those challenges. The Radarsat Constellation mission uses a trio of satellites to take daily scans of our country and its waters. Equipped with radar and ship identification systems, they collect invaluable information about our country. Satellites assist in determining ice conditions, helping captains navigate through Arctic waters and bring supplies to remote villages, and helping northern communities travel safely over ice during hunting and fishing expeditions. Satellites monitor soil stability and changes in the permafrost and gather important data that contributes to understanding climate change, so we can better protect our environment and our wildlife. To maximize crop yields, farmers use satellite data to measure moisture levels in soil, reducing how much water, pesticide, and fertilizer they use in order to protect and improve the environment for years to come. And when disasters strike and people are in danger, satellite images help rescue teams respond faster, saving lives and reducing the impact on people and infrastructure. The Radarsat Constellation satellites work together to bring solutions to important challenges that affect all Canadians. The Canadian Space Agency, finding solutions for a better Canada.
We're currently about 3 minutes away from liftoff. Falcon 9 is now moving into the final stages of our countdown. The first and second stages are both nearly fully loaded with 1 million pounds of kerosene fuel and liquid oxygen. At T-minus 60 seconds, be sure to listen for the call out that F9 is in startup. This means that the rocket's autonomous internal flight computers have taken over the launch countdown. The Radarsat payloads continue to be healthy. The F9 team is tracking no issues on the rocket. Weather is looking foggy, but good. And the range is green for launch. Let's listen in to the countdown nets now.
Stage 2, LOX load closing out. Falcon 9 is on internal power. Falcon 9 is in startup. Stage 2 pressing for flight.
Falcon 9 radar set, go for launch and landing.
T-minus 30 seconds, stand by for the countdown.
Stage 1 pressing for flight. Falcon 9 is configured for flight.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. Lift off the Falcon 9.
Vehicle is pitching downrange.
Stage 1 propulsion is now.
Power and telemetry nominal.
As you just saw, Falcon 9 had an on-time liftoff through the fog
Acquisition signal,
from
Hawthorne.
Vandenberg Air Force Base. Approaching max Q.
Vehicle is supersonic. Vehicle is passing through maximum dynamic pressure.
We now have 3 events coming up in rapid succession. Main engine cutoff, stage separation, and second engine start 1, or SES 1. All of these things you can follow along with on the timeline at the bottom of your screen. Main engine cutoff coming up soon. This is where all 9 engines of F9 will shut down. Trajectory is looking good.
Miko.
Stage separation confirmed.
And there on your screen, you can see that we have visual confirmation of main engine cutoff, stage separation, and second engine start 1. So on the left-hand side of your screen, we'll watch the first stage as it begins its return back to Vandenberg Air Force Base. On the right-hand side of your screen, you can see the second engine as it begins to carry the 3 Radarsat satellites to sun-synchronous orbit. So boost back burn has begun. There you just saw fairing deployment. It's a pretty cool shot of the fairing flying away. And we have about 10 seconds left in the boost back burn. So the shot you see on your left is from inside the interstage. And boost back, confirmation of boost back shutdown. So in order for the first stage to make its way back to landing zone 1 at Vandenberg Air Force Base, it has to execute a series of 3 burns. The first, which you just saw, is what we call the boost back burn, and that helps to slow the rocket down and orient it for entry. Shortly after this, the grid fins, which you see right there, articulating as they help steer the rocket back to Vandenberg, those are deployed to help guide the rocket during its descent. Following that, Falcon 9 executes its entry burn, and that slows itself down before hitting the dense part of the atmosphere. The entry burn actually cuts the first stage speed almost in half. So that's what will be coming up next at about the T+6 minute mark. The third and final burn that stage 1 will execute today is the landing burn. Happens to be everybody's favorite burn, and that takes place just before touchdown as the booster touches down softly on the ground. So if you happen to be in the greater Vandenberg Air Force Base area, I recommend that you head outside because you are very likely in range to experience the sonic boom that comes with re-entry. So at T+5 minutes now, we have confirmation that MVAC power is good. Trajectory is looking good. Despite the foggy view from this morning, everything is looking good. We are 10 seconds till entry burn.
Stage 1 entry burn has started.
Confirmation that stage 1 entry burn has started. So there on the left-hand side of your screen, you see the first stage as it's making its way back to landing zone 1 at Vandenberg Air Force Base with the help of the grid fins as it steers. The view on your right is the same operation that we have going on, just from a different camera. So there you can see that we have confirmation of stage 1 entry burn shutdown. Stage 2 on the right-hand side there, looking good. Everything is nominal and trajectory is good.
Stage 1 FTS is safe.
Slowly but surely you can see the layer of fog reapproaching on the left-hand side as we have a view from the top of the first stage rocket looking down the rocket towards the engine section. You heard the call out for stage 1 transonic.
Stage 1, landing burn has started.
Landing burn has begun. Due to the fog, we might lose the video as it touches down, but stay tuned.
Landing legs are deployed.
Okay, there you can see. There you can see, again through the fog, but at least a little bit more clearly this time, Falcon 9 has landed at Landing Zone 1 back at Vandenberg Air Force Base. So with that good news, we turn back into second stage, our primary mission, as it continues to carry the 3 Radarsat constellation satellites to sun-synchronous orbit. That's a shot of the MVAC nozzle as it burns through. And there we had confirmation of second engine cutoff, or SECO. So now we're just going to wait for confirmation of second stage good orbit.